Number 15 says find f double prime of 1 if this is our function here. F double prime of 1 says find f double prime of x and then plug in x equals 1. So we're going to go ahead and rewrite this with exponents. So I have x to the 1/2 plus 2x to the negative first minus 3x squared. That's a 2. So I'm going to find the second derivative. So we have f prime of x equals 1/2 x to the negative 1/2 minus 2x to the negative 2 minus 6x. And then I'll keep going. F double prime of x is equal to negative 1/4 x to the negative 3/2 plus 4x to the negative third minus 6. That's not my answer, but I'm going to just put it on hold for a moment. So I rewrote the function. I took the derivative twice. Now I'm going to go plug in my 1. So f double prime of 1 equals negative 1/4 times 1 to the negative 3/2 plus 4 times 1 to the negative third minus 6. 1 raised to any power is 1. So same thing there. And then minus 6. So I have a negative 1/4 plus 4 minus 6. A positive 4 and a negative 6 is a negative 2. So I get negative 2 1/4, negative 2.5, whatever you want to call that. Okay? Please don't spend time on arithmetic. I want you to focus on the calculus processes. Okay? All right. Let's take a look at number 16. Find the points on the curve. So we want x and y, where the tangent line is horizontal. Horizontal lines have slope of 0. So I'm asking, where does the tangent line have a slope of 0? Well, we get the slope of the tangent line from the derivative. So I'm really saying, when is the derivative equal 0? Well, let's take the derivative. F prime of x equals 3x squared plus 6x minus 9. And I'm going to set that equal to 0 by first factoring out a 3 and then continuing to factor into x plus 3, x minus 1. So this will happen when x equals negative 3 and when x equals positive 1. And they said find the points on the curve. Well, I have the x coordinates. We're just going to go find the y coordinates that go with them. Where do we find y coordinates? We go all the way back to the beginning. So I'm going to go plug in a 1. 1 plus 3 is 4. 4 minus 9 is negative 5. And negative 5 minus 4 is negative 9. And then I should go plug in that negative 3. Negative 3 cubed is negative 27. Negative 3 squared is 9. Times 3 is a positive 27. Negative 3 times negative 9 is positive 27, and then a minus 4. So I really have a 23. I'm hoping my arithmetic works out for us. I'm not checking my answers as I go. We're going to take a look at a few of these limits in here. So limits are kind of going back a ways, and we said, you know, we have algebraic limits, we have graphical limits, we have limits to infinity, which we kind of talked about a little bit already. So number 17, they want us to find the limit as u approaches 2. We should always try to plug in the 2, but very quickly we realize we cannot. So let's try to algebraically manipulate this function. In this case, I'm going to try to factor. And we can, right? Which is great. Now, plugging in the 2 does not cause any problems, and I get a 5. Number 18 is asking about a limit as x approaches 3 from the right. And if I'm asking about from the right or from the left, and I don't give you a graph, the best thing you can do is to make your own graph. This is the parent function of 1 over x. It's been moved to the right 3, and it's been stretched a little bit. But now we can easily answer this question. Approaching 3 from the right, this graph is going up to infinity. Okay. Speaking of infinity, the next one is a limit as x approaches infinity. And we reviewed that as we did something on the front. We want to talk about a limit to infinity. We said look at where your highest exponent is on the top, look at your highest exponent on the bottom, and that leaves us with a quadratic on top and a quadratic on bottom. And 6 divided by 2 is 4, which means the limit to infinity is equal to 4, because this graph will look just like this graph in the ends. When we look at number 20, we talked about putting some trig in there. We can't plug in the 0 because of that m there. And really there's not a lot of algebraic manipulation we can do to get rid of the m in the bottom. But what I did ask you to do is I asked you to memorize this limit here. Okay, so we're going to use that to help us with this one. We said as long as this matches this, the limit is equal to 1. So I would love for this to match this, which means I need to multiply that by a 1/3, which means I should come up to the top and multiply it by 1/3. Trying to change colors so you can see what I'm doing here. So this limit in the box is a big 1, and then I still have times 1/3. Do you need to show work for these? No. I would hope that we started to see a bit of a pattern. Let's look at number 21. Again, going back to a limit as x approaches infinity. Well, this is negative infinity. So we looked for that end behavior model. What's the highest power on the top? What's the highest power on the bottom? And we reduce. And we were left with a positive x, right? 5 halves x, they're both going to look the same. And a positive x graph is going uphill. It's a line, looks like that. So if they're asking as x approaches negative infinity, that means go to the left, well, our graph is going down. And the last one on this section, number 22, we've got a lot going on in here. First of all, this one is similar to number 20 in nature. I'm going to switch to a pencil here. I'm going to break this up like an accordion. I have a 5, then I have the sign of 2x, and then I have the sign of 3x in the bottom. Again, a lot of you will look at this and know the answer without showing any work. I'm fine with that. I would love to have a 2x on the bottom, so I'm going to go out and put a 2x on the top, anywhere. I just got it out of the way. The reason I do that is because now this limit is equal to 1. If this is a 3x inside, I'd love to have a 3x on top, which means I need to go put a 3x in the bottom somewhere. This limit is now equal to 1. And then out in front, I'm going to cancel my x's, and I'm left with 2 times 5 over 3. So I have 10/3 times 1 times 1. So I have 10/3 plus. Now I need to worry about this piece. I cannot plug in the 0. But what I can do is factor out an x and get rid of that problem. And now I can plug in the 0, and I get 0 plus 1, which is 1. So my final answer is 10/3 from this piece and a positive 1 from this piece. So 10/3 plus 3/3 is 13/3.